Welcome to Challis Volcanics. My name is Steve. I'm here with Brittany. We're going to take you into the Challis Volcanic area, give you a presentation, and show you how the area looks. The Challis area is located in central Idaho to the eastern side, and on the picture on the right you can see the three fingers that extend down from the Challis region. And the Challis region also covers a little bit to the west and a little bit to the north. So where on earth is Challis? Well, we're going to take you there using the power of Google Earth. So we're zooming into Mount Breinbach. Mount Breinbach is one of the higher peaks in the Challis area, and it is on the western side of it. And we'll just sort of show you around. You can look at all the nice geological features that are extending in the area from the glacier valleys to the aerates and horns that you see. Right here is Big Creek Peak, and this is on the eastern side of the Challis Volcanics. And if you look down, we'll zoom into it, but if you look down you can see a nice cirque, and in this region there is quite a bit of cirques around, along with paternoster lakes and glacial valleys.
There are several rock types in the Challis volcanic region. In order of decreasing abundance, the primary rock types in the region are andesite lava flows and tuff breccias, dacite lava flows and flow breccia, volcaniclastic sedimentary rocks, lithic tuff, non-volcanic conglomerate, and rhyolite dikes. The base non-volcanic conglomerate was deposited before volcanic activity. Andesite was the first volcanic rock deposited and the most abundant lava flow in the region. This was overlain by volcaniclastic sedimentary rocks. After that, a dacite flow was deposited. Again, volcaniclastic sedimentary rocks were deposited. Next, an ash flow was deposited, creating tuff. A smaller eruption deposited a thin layer of andesite and dacite lava flow, and that was overlain by non-volcanic sedimentary rocks. Then rhyolite dikes included the area. Igneous activity occurred in two main phases. The first phase began around 50 million years ago. It was a shallow subduction of the oceanic Farallon plate, which uplifted and exposed the Idaho batholith. The second phase occurred between 50 to 45 million years ago. In the second phase, the subduction of the Farallon plate became steeper, resulting in the rise of Challis plumes, creating Challis volcanics and explosive calderas. This resulted in lava flows as well as high explosive ash flows. The explosive ash flows caused the collapse of many calderas in the area. Less violent eruptions occurred until about 39 million years ago. The intrusion of rhyolitic structures occurred in later stages of volcanism. The Challis volcanics are 40 to 50 million years old. This is based on argon-argon dating and relative dating techniques. Argon-argon dating is a type of radiometric dating and uses the decay ratio of potassium to argon to determine a radiometric date for a geologic event. Relative dating techniques were also used, with superpositioning and cross-cutting relationships being the major techniques.
So some of the structural features we have in the Challis National Forest is aerates, and as you can see in this picture, this is one of the many aerates that come down. This view is looking in from the south up north, and as you can see, it also helps create that the glacial valleys on the right and the left. Another dominant structural feature in Challis is cirques. As you can see, this is just one of the many ones that are out there. Another structural feature we have is Paternoster Lakes. As you can see in this picture, there's two lakes to the right-hand side, and there's a couple other smaller ones that if you were to zoom in, you could see that were just above those. And once again, those are very common throughout this area. So what we have here is a horn. This is one of the most common features that we have in Challis, and this is just one of the many ones. This one is, I think, around 9,000 feet. I don't have the name of it, but it's very common, and this is one of the predominant features that make up this area.
The geologic history of the area involves three main episodes. The first was a generally quiet time in the early Eocene, with no big volcanic activity in the area. In the later part of the Eocene, about 50 million years ago, there was a boom in volcanic activity, which deposited many rocks that are in the area today. After the volcanic period in the Eocene, the area was covered in glaciers in the Pleistocene. This glaciated period eroded much of the land, creating the topographic features that exist today. This illustration shows the glaciation during the Pleistocene. In the next slide, you'll be able to see valleys formed from the glaciation during the Pleistocene.
So the topography of these of this Challis area, a lot of it is carved by these monster glaciers that have traveled to the south, and this is looking in from the north, looking south, and as you can see in the middle, it created this nice glacier valley with the high mountains on both sides. This is another cross view of that same valley, and you can see how it has the elevation is much lower down in the very bottom, where it's actually green vegetation compared to the snow caps on the top. And this is one other view from the topography. This is what it really looks like. It's high peaks coming up everywhere. It's definitely not flat by any means, and the elevation in these areas the majority of them are well over 1 mile high.
The Challis Volcanic area has several natural resources, the main ones being timber, gold and silver mining, and rock quarries. But timber is really the main natural resource in the area. About 396,000 acres are used for timber, which is 28% of the Challis Volcanic land area. And there are several natural hazards associated with the Challis Volcanic area. There are forest fires that occur, rock slides, flash floods, and earthquakes. However, earthquakes happens to be a very predominant natural hazard. A substantial amount of earthquakes are located in the Challis area. As you can see from this picture, most of the earthquakes that actually happen in Idaho happen in the Challis Volcanic region.
So for entertainment, I decided to include this into our slideshow because it's all sort of geology based. You have geothermal hot springs in the area, and there is quite a few geothermal hot springs in that area. And these pictures are of actual geothermal hot springs in the area. Another sort of entertaining thing people like to do is try and take their luck with gold panning. Haven't heard of anybody getting any. And of course there's always hiking and fishing in these high mountain lakes. We'd like to give credit to all these people that have given us these pictures, and including Google Earth, who has supplied us with the nice videos of the area. Thank you so much for watching or listening or viewing our presentation.